So picking up where we left off, we're going to work on the cosine of 3 pi over 4, which is one of those pi over 4 references a 45-degree angle, but it's here in quadrant 2. So our coordinates here are negative square root of 2 over 2, square root of 2 over 2, and this is my cosine, and this is my sine. Their values, that's my cosine of theta, my sine of theta. So we're being asked for the cosine of 3 pi over 4, which is exactly equal to negative square root of 2 over 2, and approximately equal to, if we plug that into the calculator, negative 0.7071, but let's just call that negative 0.71, because who could graph that to that precision of 1,000th place? So we'll just call it negative 0.71. So go ahead and transfer that to your little yellow sheet. And this time I'm going to press pause again. All right, so we're recording again. So now we're at the sine of negative pi over 6, which means we have to work in reverse. So it's the same as pi over 6, but we're going to go down pi over 6 instead of up pi over 6. So we're going to go down 30 degrees, because pi over 6 is 30 degrees. Pi over 6 is 30 degrees. Okay, so this is this angle here. I'm going to put that angle in there. I should have put this one over here. All right, so our coordinates down here in quadrant 4, our x is positive, and that is the square root of 3 over 2, and then our y is negative 1/2. Here's our cosine, here's our sine. Okay? So first of all, I could also say that the sine of negative pi over 6 is the same as the angle negative pi over 6 is the same as the angle 11 pi over 6. They're coterminal, but if I'm on the unit circle in one positive rotation, I'm at 11 pi over 6, which will be useful when you're writing this down on your card. So we're going to do the sine of negative pi over 6 is the same, coterminal to the sine of 11 pi over 6. And the sine is our y coordinate, so the sine of this value, or this angle value, is negative 1/2. So you could go to the sine of 11 pi over 6, which is on the bottom of your paper, and just write that real quick. Sine of 11 pi over 6. Okay, negative 1/2. All right, so now we're moving on to D, where we're going to find the secant of 4 pi over 3. Okay? But remember, I want you to decompose these into sine and cosine. Secant is a reciprocal of cosine. So I'm going to rewrite this as 1 over the cosine of 4 pi over 3. That way I can use my x-coordinate to find my secant value. Okay? So 4 pi over 3 would be here. It's a reference of 60 degrees in quadrant 3, 4 pi over 3. So that's 4 pi over 3. My coordinates here are negative 1/2, negative square root of 3 over 2. And so if I'm working on cosine, cosine is my x-coordinate, sine is my y-coordinate. So I'm doing 1 over negative 1/2. And I'm just bringing this value down here so I have room to write. You probably have room on your paper. So let's divide that. 1 divided by negative 1/2 is the same as 1 times, keep, change, flip. Right? That's 1 times negative 2. So your answer is negative 2. So what you can do here quickly is go to your 4 pi over 3. Right? And actually you could transfer your sine, which is negative 3 pi over 2, your cosine, which is negative 1/2, and now you have your secant, which is negative 2. You could fill in all 3 of those. I don't know why I haven't been thinking of that the whole time. We should do that. So quickly go onto your yellow paper to 4 pi over 3. Put your sine in as negative 3 pi over 2. Your cosine is negative 1/2. And your secant is negative 2. Right? Your cosine, your sine. These next two go a little faster because they're on they're on axes instead of in a quadrant. Okay, so we're looking now at the cotangent of pi. Well, here's what we know, pi is right here, right? And we're on the unit circle, so this is the coordinates, -1, 0. Right, and that's our cosine, and that's our sine. And cotangent, if we deconstruct it or decompose it into terms of cosine and sine, is a reciprocal of tangent. Tangent, sine over cosine. So cotangent is cosine of pi over sine of pi. Okay, so that's x over y. So that would be -1 over 0. Can I have that? No. So guess what? The cotangent of pi is undefined. It's undefined, which means if we're graphing it, it'll have a vertical asymptote. We won't be able to graph the cotangent at pi. Okay? So you could go over now to pi. You could go to pi on your yellow sheet. Put your sine as 0, your cosine is -1, and your cotangent is u for undefined. You notice how I'm just using sine and cosine to find all of this? I'm just using my 2 coordinates, and I'm finding my trig function values over and over again. Okay, lastly, we have -7 pi over 2. Okay, so the pi over 2s are the 90 degrees. Okay, so let's think of where is -7 pi over 2. That means we're rotating backwards, right? So I'm just going to count, and I'm going to do a little rotation with my pen. And I'm going to count I'm going to go by pi over 2, which is 1 quadrant, or 90 degrees, right? So I'm going to go backwards. This is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So right here, I'm at -7 pi over 2. You with me? Did you see how I did that? I know the pi over 2s are 90 degrees, so I just counted backwards in 90-degree increments. 1 pi over 2, 2 pi over 2, like that. Right? So what are my points right here? My coordinates are 0, 1, right? So I could say that the cosecant of -7 pi over 2 is coterminal to the cosecant of pi over 2, right? Because that's this measure right here, pi over 2, 90 degrees, pi over 2, pi cut in half. We have 180 cut in half is 90, pi cut in half is pi cut in half. So that's pi over 2. I'm going to get another line in there so you can see. All right. But we don't want cosecant. We want to decompose that into terms of sine, which is the reciprocal of cosecant. So we're going to do 1 over sine of pi over 2, which is, okay, our cosine is 0, our sine is 1. So 1 over 1 is 1. All right? So if you go on to your little yellow sheet, you can go to pi over 2, and you can put in your sine is 1, your cosine is 0, and your cosecant is 1. And you have those 3 filled out. Okay? And so we're going to, for your homework, what you're going to do is you're going to use your unit circle, and you're going to fill out the rest of the values. For your pi over 3s, your pi over 4s, and your pi over 6s. Okay? All right. Now let's do the rest of this with a calculator. Can you turn your music off, please? All right, find each of the following function values of radian measures. Okay, so this is the first time I think we're going to experience being in the wrong mode in your calculator. If we're going to find values in radian measures, we have to make sure our calculator is in radian mode instead of degree mode. So read the top of your calculator screen and make sure it says RAD, not DEG. If it says DEG, go to mode and change the mode to radians, RAD. Okay, because we are looking for these in radians. And also a note here, here's a problem. If you don't realize that this is in radians, you're in trouble. Look at this. This says the cosine of 2 pi over 5. How do I know that's not 2 pi over 5 degrees? Because there's no degree mark. So if there's no degree mark, you assume radians. You assume radians. So this is in radians. So here's my suggestion when you type these in the calculator. You're going to do this, the cosine, and do a fraction bar so that you can type it in. So you're going to type in 2 pi over 5. Hit enter and give it to me in 4 decimal places. It's quite simple. That's approximately 0.39. Correct. Okay? Now we're going to move on to the tangent of -3. Type it in. That's an easy one. No fraction necessary. It's 0 point something, but I don't know, so I need some help.
0.1425.
1425, let's get confirmation.
Yep.
Okay, thank you. All right, this next one is the sine of 24.9 radians. So the sine of 24.9, type that in. It's negative, I believe, this time. Tell me if I'm wrong. I need you to plug it in. I don't have my notes in front of me.
0.2306.
2306, let's get confirmation.
Yes.
Okay, let me make that a 6 and not a 5. All right. So that one's negative. And then secant of pi over 7. So you know we can't plug in secant of pi over 7. So we're going to have to convert that to its reciprocal value, 1 over cosine of pi over 7. So again, with the calculator, I suggest you get the fraction. You type in the 1, you hit cosine, and then you hit the fraction again, and do pi over 7. So that's my suggestion for typing it in, just the way we write it. And give me an approximate value. I believe it's greater than 1. 1099?
Yes.
Is that it?
Yes.
Okay, awesome. And so here is something else I'd like to just make clear to all of you, especially those of you that just came in. Your calculator will give you all of the trig values for all of the angles. So even the exact values on your unit circle, you could plug them into your calculator. So let's do one, just so you understand. Do the sine of pi over 3. What's nice about the little calculator is it's going to give it to you in terms of radical. So type it in. The sine of pi over 3. This should be 1/2. Or the square root of 3 over 2. And so the calculator, you'll see, will help you figure that out. So when you're doing your yellow sheet and you're a little bit stuck and you want to double check your answers before you fill out your reference sheet, you can always type them into the little calculator. You plug it into the graphing calculator. The graphing calculator will only give you the approximate values, not the exact values. Okay, so on your yellow reference sheet, for those of you watching the video, these are the two values I want. When you have an exact value that you can't graph, also provide the approximate value in decimal form. Like if you have 1/2, well, you know where 1/2 is. You don't have to change that to 0.5 to know how to graph that. But the square root of 2, you might not know where that is. So when you see the square root of 2, make sure you also put its approximate value.
It's not.
Oh, thank you. All right, and so there you go.